Here we want to find the solutions of each equation. Now we have two equations to solve here, and we want to give our answer in radians. So we want to solve for theta. When is the tangent of theta equal to 1? And when is the cotangent of theta equal to negative square root of 3? So let's start with the definition. What is the tangent function defined as, and what is the cotangent function defined as? Well, we could say that the tangent of theta is equal to the sine of theta divided by the cosine of theta. And then we have the cotangent function, which is the reciprocal of the tangent. So the cotangent of theta is 1 over the tangent, or the cosine of theta divided by the sine of theta. And in the context of the unit circle, we say that the sine of theta is equal to the y-coordinate of the terminal point after a rotation of some angle theta, and that the cosine of theta is equal to the x-coordinate of the terminal point. So if we look at the unit circle, let's look at quadrant 1, that first special point, and now these points come from those two special triangles that we have, the 30, 60, 90 right triangle and the 45, 90 right triangles. I'm not going to derive where these points come from in this video. I want to focus on solving the equations. So for an angle of either 30 degrees or pi over 6 radians, either way, you could look at angles in degrees or radians. In this problem, we're using radians. The terminal point for an angle of pi over 6 is the point square root of 3 over 2, comma, 1/2. Now you have this blank unit circle. I posted this in the course materials. You also have this the same unit circle, but with all the values filled out. You're not going to be able to use those on the exams, so this is something you have to know to do these types of problems. Okay, so we want to know let's start with this one. When is the tangent equal to 1? Well, for the tangent to equal to 1, that means the sine over the cosine has to equal 1, and the only time a fraction is equal to 1 is when the numerator is equal to the denominator. And so if we look at, let's use a different color here. If we look at an angle of pi over 4, or 45 degrees, or pi over 4 radians, the terminal point is root 2 over 2, comma, root 2 over 2. So the sine and the cosine are equal to each other. So the value of the tangent of pi over 4 is equal to 1. So we can say for part A, theta equals pi over 4. That's one solution. But if we look down in quadrant 3, so let's look at this radius here for pi over 4, and if we extend that down to quadrant 3, we have the same values, root 2 over 2 and root 2 over 2, except in quadrant 3, they're both negative. So the point would be negative root 2 over 2, comma, negative root 2 over 2. And that's an angle of 5 pi over 4 radians. Or in degrees, it would be 225, but we're working in radians. So if the sine and the cosine are both positive in quadrant 1, they're both positive root 2 over 2, then the tangent is equal to 1. And if they're both negative, negative root 2 over negative root 2 over 2, any number over itself is also equal to 1. So 5 pi over 4 would be the other solution to when the tangent is equal to 1. So we're looking at the tangent and the cotangent functions in terms of sine and cosine, and the sine and cosine are the coordinates of the terminal points for those angles. And then this angle would be the 5 pi over 4. Remember, angles are relative to the positive x-axis in a counterclockwise direction. All right, so let's look at the cotangent function. When is the cotangent equal to negative square root of 3? Well, if we look at the other point in the first quadrant, that's this one here. If the angle is 60 degrees or pi over 3 radians, we have the same values as with pi over 6, just switched. So the x-coordinate is 1/2, and the y-coordinate is root 3 over 2. Okay, but for the value of the cotangent to be negative, we need one of those coordinates to be negative. So we could look at the reflection in quadrant 2. That would be this one. So that would be an angle of 120 degrees, or 2 pi over 3 radians. And so the coordinates in quadrant 2, well, the x-coordinate would be negative, and the y-coordinate would be positive. So that would be a negative 1/2 and a positive root 3 over 2. Or if we reflect the terminal point for pi over 6, so that's this one here, if we reflect that into quadrant 2, again, the x value will be negative, so negative root 3 over 2, and the y value remains positive 1/2. Okay, and that's an angle of 150 degrees, or 5 pi over 6 radians. Now the question is, which one of those points gives us a cotangent of negative square root of 3? Well, the cotangent is the cosine over the sine. So the cotangent is x over y. So we could say that's x over y, and the tangent is y over x. So the question is, does x over y give you negative root 3, or does y over x give you negative root 3? Well, let's see. If we have the 1/2 on top and the root 3 over 2 on the bottom, we get 1 over the square root of 3. But if we have the root 3 over 2 on top and the 1/2 on the bottom, that gives us, the 2's cancel, and we have the square root of 3. So it looks like the x value has to be the root 3 over 2, and the y value has to be the 1/2. So it looks like this point right here, if you take x over y, you get negative root 3 over 2 divided by 1/2, and the 2's cancel, so you get negative square root of 3. So the cotangent, let's get rid of that, the cotangent of theta equals negative square root of 3 at an angle of 5 pi over 4 radians. Okay, so that's one solution, and then we could reflect that point into quadrant 4. And that angle would be 330 degrees, or 11 pi over 6 radians. We would have the same point, just the x-coordinate would be positive. So in quadrant 4, the x-coordinate is positive, the y-coordinate is negative. So that would be a positive root 3 over 2 and a negative 1/2. In this case, again, the x divided by the y. Positive root 3 over 2 divided by negative 1/2 would also give you negative square root of 3. So that is another solution to when the cotangent of theta is equal to negative root 3. So the second solution up here would be 11 pi over 6. So we have two solutions for when the tangent function is equal to 1. That's an angle of pi over 4 and 5 pi over 4. And then we have two solutions where the cotangent function is equal to negative root 3. That is, I said 5 pi over 6, but I wrote 5 pi over 4. So let's rewrite that. 5 pi over 6 and 11 pi over 6. All right, that about does it for this. And again, just let me stress, this being able to navigate the unit circle, this is one of those things you need to be comfortable with and knowledgeable about coming into a calculus class. We're going to be referring back to this quite often throughout the semester. All right, that about does it for this problem. I hope it was helpful.